I'm just going to go to full screen here for myself here. Right, so as I say, I've called this talk lecture, 10 years of clay extrusion 3D printing, because it was in December of 10 years ago that I got my first clay 3D printer. So my presentation for about the first half, I will talk about the experiences that I've had. And then the second half will be more technical, looking at machines, looking at clay, and looking at the way that I work. So if we move on from here, I've laid out this first screen sort of representing a time scale of the machines that I've used. So in 2010, my first machine was this Rapman machine that I'll talk about. I'll talk about all this a little bit more, but just so we get a sort of an overview at the beginning. 2013, I built my own machine that was then an open source machine. 2014, WASP gave me, one of their first machines with a prototype print head. Then I was traveling a lot, so I made one of my make your own machines as a slightly smaller version to be able to go into a suitcase and with a what we call it a retraction or an on-off print head. I wanted to work a bit bigger, so using the same design, I scaled it up. Then it got to a point around 2018 where it's actually cheaper to buy a ready-made machine from China and then customize it or make it be able to print with clay. And I will talk about this later in the talk, so that's represented here. 2018, WASP produced, they had been making a large machine, but it only had a small print head on it. So they made, a larger, a more powerful machine anyway. All the motors are bigger and with a large clay container and large print head. They've given me one to try out. And so that's that machine. And then 2020, a Chinese Cerambot sent me a sample of one of their machines to try it. So anyway, that kind of is a quick 10 years of machines. All except the first one is obviously our Delta type style of machines. This is a Cartesian machine, sort of square layout. As we go through my talk, I will discuss the pros and cons of the two. Either type of machine works perfectly all right. Actually, I think another thing I must just point out early on is obviously this machine here, the clay container is sitting right on the print head. There's no stop-start. The flow is continuous, whereas by 2014, we have a large clay container to one side that is feeding a screw print head that will then switch on and off. I like to think about printers in some ways as a rig that be it a box type thing or a Delta or even a robot arm is the rig that carries the print head, and the print head deposits the clay wherever you want it. And then you've got to devise a way to get clay to the print head. So I tend to think of it as three things. There's the rig, the print head, and then the clay container. And you can see this is a different, I'll talk about later, but different kind of clay feed. These are big clay containers. And here it's going almost back to a clay container like this, but is held next to a machine and then fed in. That for doing small samples is actually pretty useful. Right, so a little bit background of myself. I was born in South Africa, moved to the UK 30 odd years ago, and I did ceramics at school, so I've done, sort of worked in clay for many years. But it was in 1999 that I really got interested in using computers with ceramics. And I was commissioned with 10 other artists to produce a CD-ROM about my artistic practice. I was really intrigued by the way we could use software to visualize new forms. My ceramics tends to be more about form than necessarily about surface. And it was how I would be making or start to think about, visualize forms that I wouldn't otherwise make in the ceramic studio. So these are some examples of pieces made, sort of after I'd worked on computer and then before I started 3D printing. So there was a period of about 10 years where I was using the computer a lot, but not yet actually printing. So these are thrown and constructed or actually coil built. And in a way, it's just to illustrate the sort of the knowledge of ceramic background that I have, that I've brought to the 3D printing. And then Fleming is watching this and he'll be amused. But 2007 was actually kind of quite a break, or whatever the term is for me, in that Fleming was doing his PhD and he organized this symposium at Gulliagar in Denmark around digital media and physical form. It was the first time, although I was well aware of the theory of 3D printing, it was the first time I'd actually seen 3D prints. So they're sitting on the table here, 2007, but these are either plastic or plaster. There's no ceramic on the table. Well, that's ceramic, but it's thrown ceramic. And so I was quizzing these designers from the UK, designers from Denmark, quizzing them as to whether, we could work, I could transform the stuff that I had on my computer straight into ceramic form, because by now I was not exactly designing, but drawing at least my sculptural forms on computer, getting ideas on computer. And they said, to the best of their knowledge, there wasn't a system except the powder Z-Corp's machine could take powder clay. And I think this is something that Fleming was exploring, did explore. Anyway, I returned to the UK, so this is still 2007, and there was a PhD offered at Falmouth in Cornwall in the UK that I applied for, and my project was to develop studio-based ceramic 3D printing. I didn't get the PhD, but this is what I was looking at the time. From the symposium organized by Fleming, I returned to the UK, started researching, ways that I could start 3D printing. But for me, I wanted it in my studio. I didn't want to send my files off to a bureau to get printed. I wanted the whole working process to be part of, I'm kind of that studio background that I have. So anyway, in my research, David Herold, producing the slipjet printer, 2001. So, I suppose he's the granddaddy of the system, that there is a little mini computer in here that is driving this revolving bed, and there's a pump over here pumping clay through. So, it's how we work now, but well, I like the Heath Robertson aspect to this, but, the very DIY system. But this was, the principle that could be used. In my proposal for the PhD, it was to look at both extrusion printing, or sort of coil building as such, but also the potential of powder printing. Because, my knowledge of coil building, I knew that there was going to be this problem. I could foresee there would be this problem of support. How is the soft clay going to stand up? And powder printing is one way of overcoming this. And this Candy Fab was a project I saw coming out the USA, where somebody had hacked a printer basically, or a plotter, and put a heat gun on the plotter. They then have the bed of sugar in this case, because it's Candy Fab, and the heat gun then melts the sugar. Now, a bit like a Z-Corp's powder printer that used an inkjet, I was thinking, how could we extrude clay onto a bed of powder clay? This would then be manually, the Z or the bed would be manually dropped and a new layer of powder put on, and it would slowly be built up to make. So the principle was there anyway. And then the other, strong feature at the time was the RepRap project by Adrian Bauer, coming out of Bristol University. And I emailed Adrian Bauer and said, what's the chance of being able to put a clay print head onto, his early prototype machines. And he said, it's quite possible. So I actually spent quite a lot of time experimenting with syringes to see what consistency of clay would be. But where I was hoping that he might say, we'll come to Bristol and let's talk about this. I didn't push it, but he didn't invite me either. Anyway, and I had other work to do. So it wasn't until 2010, I kept checking, the internet to see, what came up under ceramic 3D printing. And then finally, 2010, this popped into view. So Dries and Claire, Dries van Bruggen, Claire Warnier, Unfold Design Group in Antwerp, Belgium, they sort of cracked mechanizing it as such. So this was in the October or November of 2010. I went over and visited them and I copied their system. So what we were doing is buying a very early kit 3D printer, plastic printer. We didn't put the plastic print head on. We would just put on syringes, pressurized from an air compressor. To begin with, they were only one of these sort of 60 mil syringes or something that would make a cup that big, but was a bit too small for what I was hoping to do. So I sort of was making double syringes. Anyway, so I think 2012, there was a research unit down at Bristol. Adrian Bauer was at Bath University down. Anyway, there was a print research unit for 2D and 3D print at Bristol University. And they, in 2012, I think in the January, February 2012, organized a one-day symposium at the V&A around the potential of ceramic 3D printing. And they had a powder printer, the Z-Corps machine, and that's what they've been working with. And they asked me to present what I was doing with the clay extrusion. And from that lecture, sort of interest went out. I'd also been posting videos to YouTube. Anyway, Charlie Stern, who was in Stockholm, contacted me and asked if I would set up a rep-wrap machine for them at the Royal Institute of Art in Stockholm. So this sort of started becoming, I guess, my income. I've always been a self-employed artist. In the past, I had made domestic ware pottery, but I live by the sale of my pottery or any other, teaching or such like that I can do. So anyway, I set up this machine for Charlie, and then Fleming similarly asked if I would set up a machine in Copenhagen. So 2012, set up this and then did a workshop with Fleming. Result of that. Falmouth, where I didn't manage to get the PhD, were good enough to invite me back for a short residency. Now, this is my machine, and although I did use it just as an unsupported extruding machine, as in these images, I was still kind of, because my forms are very rounded, was interested in this idea of being able to support or use powder support to print with. So the principles of these Cartesian machines is such that the print head actually stays at one level and goes in the XY direction. These 3D printers ultimately only being 2D printers. They move, in 2D, and then the base slowly falls away, creating the third dimension as the work gets piled up, as the coils of clay get piled up. So what I was did here is the base or print board would disappear into this Perspex box. And as it did so, I would then spoon in powdered clay. And then this would offer support to be able to make very cool curved sort of forms. So within this presentation, as I say, it's quite technical, but I have then just slotted in work that represents what I was doing at sort of that time in the timeline. So these porcelain pieces that were shown at the British Biennale 2013, when I look back on it now, really interesting that I was 10 people in this, the main exhibition. I had no response to the work whatsoever, no emails. It was quite odd to be doing what I thought was quite progressive work, but just silence. So I can't remember the exact time span, but around 2012, this was now part of my business, was doing workshops, setting up the RepRap machines for people. And 3D Systems, a big American company, bought out the little startup Bits for Bytes that were making the RepRap machine. They were based down in Somerset. That machine had actually come out of the Adrian Bauer University project. So you can see how it's all kind of linked. But anyway, 3D Systems bought out the little Rap Man and totally flattened it. They stopped the production of it, obviously protecting other machines. By now a community had built up. Dries van Bruggen was very involved in that. It was horrendous that, you have this sort of open source community feel around a machine, and it's the community that is giving the input into the knowledge for developers to develop. And then a multinational can come in and just, take that all away. They stop the production of the machine. The online community forum was taken offline. Fortunately, I think people managed to actually download it before it was taken offline. But it got, I was left thinking, right, I want to print bigger. I want, a more developed machine than the little Rat Man. And looking online, I felt there was enough information that I could build my own machine. And that's what I did. And then having built it, I thought, right, okay, now is this my new sort of cash flow? Am I going to build machines? And I thought, my interest is making work. I don't want to make machines. And then two, I just don't want to get caught up in the aftercare and all of that. So what I did to make sure that the kind of the knowledge that was slowly being built couldn't be flattened by sort of business as such. I open sourced this online. And at the time, possibly a little naively, I just sort of thought, oh, well, a bit showy off, this is what I've managed to do. And it's had a YouTube video that went with it, this, that, and the other. But I sort of didn't stop to think what influence that might have. To say something like showing work at the BCB didn't have any response, but putting a machine online suddenly had a big response. Anyway, Gulligo out in Denmark, and I think this is probably prompted by Fleming as well, asked if I would build a machine and supply them with a machine, that I did so. This is the International Research Center. And so there was a technician there, and the technician had to, get to know how to use the machine. So I sort of taught the technician, but we also did some videos. And I found that, again, looking back in retrospect, the videos were made just for the research center, but we put them online, and they've become a useful resource, I think, for a lot of people. So sort of one does these things not really thinking it through as to what the wider influence might be. But now I've got to the point where you just sort of put the stuff out there, and you never know where it'll go, but the important thing is to put it out there. So Enkelsholm Folk High School heard about me setting up a machine at the ceramic center, so they asked if I'd do a machine. I've never been in the position to really say no to things, so I did that. I went back there a good number of times and did some workshops. And this image here is actually from a workshop I did around the idea of sound. Within the school, they had digital, a department doing digital sound, and then they had the 3D department. and we did a one-week workshop between musicians and 3D sculptors, glass blowers, ceramic artists. Really, really interesting. Hard to do, but interesting. Having built this machine, again, I was concentrating on what I wanted it for, and that was for coil building, basically computer-guided coil building. But other people had other interests. So Berghalle University, it was their materials library got me out. They built a machine. So by now I was saying, right, the institution, I'm not going to build machines. The institution build the machine, and I will follow along and do the workshop. This workshop was about trying different materials in the machine. So, the one machine we were trying wax and cookie dough and wood pulp and so on and so forth. A museum in Zurich persuaded me to build a chocolate machine. I think they had promised in a funding bid that they would be printing food or printing chocolate. So it was a bit of a desperation in very short time, but they paid me well. And it was nice to be working with a Swiss chocolate company printing in chocolate. So I guess my business model, that makes me sound like I sort of am business orientated, but there's the reality: you need to make your livelihood. And I live here about 100 miles, 100 and something, 160, 140 kilometers north of London. There wasn't an institution I could sort of attach myself into in the UK. Institutions in the UK really weren't inviting me anyway. And I was getting invitations from, further afield. So in a way, what's happened is that I've ended up, I counted it up to, put this list of institutions together, 50-something workshops. Now, a workshop might be a one-day sort of workshop through to a 2-week workshop. And in Iceland, I've been done 3 workshops over there over 6 years. France, I've done a fair amount of time. And then over in Tallinn, there's been the summer schools that I've attended for 3, and I think there have been at least 4, if not more, summer schools. And obviously there's trips out to America and a trip out to China as well. But, sort of it shows the breadth of interest that there has been around clay printing. Most of it within arts design schools, from my experience anyway. Ceramic festivals, a little, museums. I think rather nice, fab labs that working in ceramic, quite often it gets ghettoized, that ceramics just speaks to ceramics the whole time. I think the interesting thing here is that one's combining, sort of technology and clay and whatever else. So, working with fab labs, materials library, I flagged up the Berghalle, but, they've been University College of London. It was in their materials lab, fab lab, that I worked rather than with any one department, either with fine art or with architecture. It becomes a resource for a number of departments. I think it's an interesting way forward. And then being invited to digital festivals, something like Ars Electronica in Austria. Right, so as I say, these are some of the institutions I visited, and then I've just tried to sort of use them as a reminder for myself to talk about them in a way. So in Richmond, Virginia Commonwealth University, I don't think you'll be able to see awfully well, but it was actually the engineering department that invited me out. And more specifically, the medical engineering department, because they had a professor who was really interested in this idea of interdisciplinary sort of knowledge. And so although I gave, my artist lecture over in the art and design department, he was trying to get links between sort of art and science. And his particular interest and sort of why I invited me out was to see whether we could somehow get enough knowledge from neurosurgeons, from sort of people specializing in brain, to be able to get brain data, to be able to print objects, possibly POTS, that represented the amount of pain that patients were going through. I, in 2000, did a residency in doctor surgeries using the POT form as a sort of vehicle for patients to be able to talk about their well-being. So it was an area I had worked in before, and this is before working digitally in a way. Florida State, Robbie Nowell, sitting here. As I said, my sort of what I would offer was that the institution would build the printer, and then I would come and do the workshop. So when I arrived, this was what I was confronted with, a half-completed printer. So the workshop started a day or two late. But anyway, it all sorts out. But the point I wanted to make here was that inevitably, well, not uncommonly, there's this collaboration or cooperation between the technologists who are doing the machine and then the artists who are wanting to use the machine. I fear that very often the technology actually takes over from the requirement. And this is the point I want to make, is the technology or the technologists take over from the requirements of the artistic requirement. And that is that, the engineering possibilities are almost endless. And you get there and the technologist is saying, oh, well, let's do this, let's alter this bit, we can improve it here. And you say, no, just calm down. I just want a simple machine that will do the job that I want. And I don't want to be hamstrung, held back by all sorts of extra little bits. And I think there has to be a balance between what tech is required and then what can be got out of that tech. Denver University, the 2 weeks that I spent there, they built two machines, Mia Merv, ceramic lecturer, now I trust professor. But what I wanted to point out was that I think she healthily had a very kind of overarching view of the way to introduce digital technologies into the studio. And that was the 3D printer was only part of the bigger package. She didn't concentrate on 3D printing. She was concentrating on this new tool set, the computer, that can do 3D computer drawing. And then once you've got a 3D model, you might want to print it, or you might actually want to cast it. So she, along with the printers, had also set up a CNC cutting machine. So working with this blue foam here, with a digital file, they could cut the positive shape and then take plaster Paris molds off that. So very quickly, you could actually make up a set of molds and cast an object. So looking at your digital drawing, you might decide, it actually is better to cast it than 3D print it. And I think this is something that departments actually need to look at, and that's not concentrate on one process or the other, but it's more to marry up, the use of digital tool sets within a department. 2014, work of mine being included in the Taiwanese ceramic Biennale. So these are porcelain iceberg pieces. Another project that was, it's been kind of very influential to me that wasn't, particularly clay or only clay, and that is from 2013 to 18, I was engaged as a sort of design stroke technical assistant consultant, what you want, to an education program that was first funded by Comenius funding and then Erasmus funding. So there were two-year sessions. And it was looking at how 3D printing would be integrated into teaching it within schools. And that was from very early years right through to, are there some mature students? Actually, there aren't, but anyway, right up to mature students. It was really, again, interesting to, the dates right from 2013 when there weren't many tabletop machines, and what machines there were very expensive. So this was out in Holland, but somebody's Kit's Ultimaker machine. And then by 2018, the price had really, really fallen, and you could get a high quality plastic printing. And one had, sort of saw this development. So within the brief to the teachers, this was trying to work out what hardware was useful in the form of printers. Is a scanner being used here, and how scanning might be used within schools. But then also the software side of it. So 2013, when we started up, it was SketchUp, Blender, 123D something, the Autodesk software. But software is really difficult. But within the 5 years, Tinkercad was an absolute godsend for teaching younger children, and I think the elderly as well. I mean, Tinkercad is a great piece of very useful software. Fusion 360, and then I use Blender. Other images here, mobile, Fab Lab out in Holland. The schools that we worked with were in Sweden, Finland, down to Spain. The idea was that the teacher group would, through the year, visit each one of the different schools within the group, within the project, to see how 3D printing and new technologies have been integrated into the classroom. And then at the same time, on each visit, the hosting school would try and take us out to the community and see how the new technologies have been used. So this was done in Spain, a model making company using this technology. This year was a workshop that I did in Vlieland, that is an island, one of those islands off the north of Holland, with the schools looking at using clay printing to make curios. The idea that you're on an island, it's a holiday destination. And I thought the flip-flop was a really lovely solution. And then there was always downtime, and downtime with teachers is pretty entertaining. This project with Charlie Stern, who's already appeared, and Dries and Claire from Unfold. Charlie put this together. He raised the funds for himself, myself, and Unfold to work together looking at how digital techniques could be used, combining both studio glass and studio ceramics in some ways. I say studio as a shorthand for handmade or, sort of artisanal rather than industrial techniques, or, although one is using industrial techniques at the same time. So we had a period of time at Konstfack in Stockholm, really just experimenting, producing a lot of shards, just seeing how the two materials can combine, what techniques to use. Would we be making molds for the glass? Do we integrate the two materials? And then we spent a further period out at the glass studio in Småland, actually doing a short batch production. And so you can see the sort of material, I've always been interested in materials and what clay can do, and the idea of raku firing and so on and so forth. What we were doing with the clay is, here, a bit like a raku firing, the clay has been, or the glass has been blown into the clay, and the clay is going back into the glory hole. So we're having to, really choose what sort of clays we were using. This was the sort of production line or short range that we produced out of that project. So it's 3D printed ceramic with blown glass into it. And the color one is seeing is the unglazed, but the body color of the clay. So my friendship with WASP, collaboration with WASP, must have been 2014. I gave a lecture at Ceramic Art London, and Giuseppe Olmetti here was at that lecture, and he asked if I would then do a workshop at the Fab Lab in Faenza, out in Italy. And I said, yeah, no, I'm very happy to do that. But I also know that the WASP group, who by then had been doing a lot of clay 3D printing as well, worked in the area, and that I must meet up with them and sort of introduce myself and so on and so forth. Anyway, so I did my workshop at the Fab Lab, and then was introduced to WASP, and so then WASP during the festival had the stand in the streets in Faenza, and not surprising, because the commonality of clay 3D printing, we really hit it off and have become good friends and set up a good working relationship. But so it's 2014, working in Faenza with them while I'm sort of demonstrating. You can see a largish machine. At this stage, you can see there's a clay container, large clay container, extruding clay, but they hadn't yet devised a on-off retraction type printhead. A larger machine over here, and this was being fed with this machine that was a peristaltic pump. So it's behind this chair, so you can't actually see it. But already they were concerning themselves on how to feed enough clay to be able to build largest objects. So Massimo, who's actually down here, Massimo Moretti, who's the kind of guiding force behind WASP, his ideal has always been to be able to build relief housing using clay, unfired clay. I think in the background, there's my little machine quietly sitting on the table. So WASP had been, WASP and I had been watching each other online as to, sort of as we posted stuff as to what was happening. And so it's really, great to come together. And it was, this 2014, so August 2014, they were saying, oh, we really do need to, and I was agreeing, control and on-off to when we're printing. This, sort of a screw or auger in the printhead to switch on and off was something that Unfold had experimented with in 2012, but to the best of my knowledge, hadn't carried it forward. And I said that there was this technology to set it to WASP. I think WASP were already on it. Within months, they developed a stop-start screw head. 2015, so that was the next year. I then actually visited and stayed for a period working with them out in Italy. And on this occasion, we did a number of experiments with alcohol. This is, something that WASP had been trying out, this idea that, when you're printing, you want the clay to dry quickly, and set its shape. So how about using alcohol to moisten the clay rather than using water? And sitting on the table here is actually a bottle of bio-alcohol. I certainly think there's something in it. The experiments we did, the trouble is you get a very strong alcohol fumes coming off the whole time. And working in Italy, where we could sort of open the doors and that it might be all right, but working in my own studio in the UK, that's normally quite cool. I have it's not ventilated enough. So bioalcohol is something I haven't worked, I've tried and there might be something in it, but I've managed without it. So 2005, WASP were, building this large Delta printer. Sorry, I've just noticed the time. I'm going to have to rattle along here. for trying to build houses with. Some examples of mine shown in Boston Museum of Fine Arts. So these are sound surface pieces, so musical extracts from the sea interludes have been plotted onto the surface of the piece. So from base up to rim is a spiraling sort of representation of the volume and the rhythm of the music. This is the art school down in Limoges in France. Michel Pissant, who set up this course. Interesting course in that his premise was to offer a post-degree diploma and within an art school, both fine art and design, offering something where students could use new technologies, new materials, and just new ways of working. So I think I've run 3 courses out there. The student course is much larger than just 3D printing. 3D printing and clay 3D printing more specifically is just one element of it that I work on. So you can see that sort of one of the end of year shows, quite a lot of glass, and that is because for a period we'd go out to the Meisenthal glass factory in northeast France and try and combine ceramic and glass. So something that happened here is you can see the 3D printers. We had been printing back in Limoges in the middle of France, perfectly all right. Took the same Limoges porcelain out to the Meisenthal factory, and for a week I just could not get these machines to work well. The machine where the clay was just pushed straight through, my old machines without a screw auger to them were all right, but the augers were problematic. Looking at the character of the clay, I just realized this clay is becoming, I can't even say the word thryxosopic, but anyway, it's deflocculated. Again, I bring this up because a bit like the alcohol thing, these are additives that might be added to clay to improve the quality of the printing. People say, how about using the sort of clay that is used for slip casting, because slip casting clay has got less water in it, so it's going to hopefully dry quicker. But the problem is that when you do that, then the clay has no bite to it, that the screw can't really bite. The clay almost goes to jelly, and the screw doesn't bite on it, and it doesn't layer up very well when you want to come to print with it. So it was a bit of a hard learning curve, but it was a case of realizing that if anything, you need your clay to be slightly on the acid side than on the alkaline side. My interpretation of it is that because we were in this region that is, sort of obviously good for, sand for glass making, this is a traditional glass making area going back, literally hundreds of years. I assume the water in the area, I haven't had it tested, but the water in the area is very alkaline. So if you've got alkaline water and you are adding it to particularly porcelain clay, it very easily goes thryxosopic anyway. So a little bit of vinegar is the answer. Start working in Limoges. I think what is interesting for me here is that you had students sort of demanding jewellery students wanting to work on a very small scale, through to other more conceptual students who would want to just make as tall a object as they could. So it was really testing what we could do with the machines. This was one of the courses that I led out there, and rather than sort of facing up and saying, this is going to be a 3D printing course, I said, right, no, what we're going to do is deal with this idea of cut, copy, and paste. That is something, the digital ways of working really offers. So we looked much more at scanning, and then, sort of what we call it, mixing stuff together. And so the 3D printing just became, something within the project, but it wasn't the actual focus that I think worked quite well. And then students really looking at that point where it breaks down, that fine line between where it's building and where it's not building. This slide here is to represent something that, I think is really kind of works well and is important, and that is rather teaching teachers. So a fair number of the workshops I've done have actually been staff development rather than just, than for students. You can see with staff development, you then get fruit and coffee and chocolate. And the point here is obviously you sort of building pyramids, that if you can get staff up to speed, then the education is going to expand so much more than if you're just teaching an individual student who might well go on and teach further, more people later on. This here in Swansea in Wales, they were building a machine themselves. I brought in my own machines so that we had lots of machines to work with. Out in Cardiff, this is one time, we were working with extrusion machines, but they also had a form lab. So this is a printer that is normally made for working in plastic, but you can also put a ceramic type resin into it. So, but we just didn't have time to really sort it out. And this a staff development out in Ireland, I sort of flag this up because it's not uncommon that the staff, say within a fine art department, get brought in to have to do the staff development. And they just, this was a case where I had a mature sculptor who said, I'm not interested in digital. I work my stuff, I work by hand. I like the idea of drawing on pieces of paper and so forth. I'm not going to spend my time learning, the software and so forth. He said, no, come, you have to do the course kind of thing. I wasn't saying that, their superiors were. So in this case, working with Tinkercad, within 2 days, this guy, as I say, a mature teacher, was quite transformed. He said, hey, I now see the point of this, that you can start, sort of manipulating forms, you can start visualizing forms in such a better way than you necessarily can. Well, it's an add-on. I'm not trying to say it's going to take over from pen and paper. Pencil and paper. I'm a great advocate of pencil and paper. But if you can actually spin a three-dimensional form in virtual space, before you commit it to form, why not? I work on my own, the Biennale in China. So these are digital drawings, printed porcelain, printed stoneware. The color in here is color added to the clay. And then a digital animation happening as well, digital animated drawing. So say I've done a number of courses out in Reykjavik, and there what they do is they ask me to do the course, and I rather like, they call it computer draw, they want me to teach computer drawing. So it's not CAD or anything like that, computer-aided design. It is just plainly, and I like to think about this, it is drawing in 3 dimensions in a computer and then transferring that over into physical objects through the printing. But more than that, what I wanted to talk about here, or remind myself to talk about here, is the point of gender. Interestingly, the first course that I did in 2015, it was an all-female group. The other 2 sessions that I've done were more mixed, but it's not uncommon that a lot of the courses that I teach to, there's a bias towards females in the course. But if you sort of kind of look online, it's not uncommon that all the development of machines and the technology is being done by males. there's obviously something about the male brain, and I include myself in that kind of warms to all the tech and so on and so forth. But it's coming back to that point I was trying to bring up with Robbie earlier on, and the technologist, is that we must bear in mind that the technology must not take over from what is required by the actual user. I'm a great advocate of saying just keep it simple, because that within a workshop there is no gender divide. The female participants are producing work just at the same level as any male. But as I say, if you go into a fab lab, it's not that there isn't a mix of genders, but within a fab lab, it's not uncommon for there to be more men fiddling around with the machines. But when it actually comes to doing something with the technology, it's an absolute level playing field. I have no problem with that at all. Teaching at RCA, RCA finally set up printers and I set them up in 2008. It was actually Rod Bamford who bought the machines. He spoke to me and I said and visited as to whether to go with a Cartesian type, sort of more the cube type format for printing, or a delta type format. And I said, there are strengths and weaknesses. I think that the cube is advantageous for wider printing and deeper printing. In other words, sort of for lateral, where a delta printer its strength is actually in the vertical. Probably they tend to slow up as you get wider, and as you get wider, you have to have longer arms. So I think that's sort of the one strength and weakness between these two machines. Rod managed to get the budget to be able to buy one of each machine. So this is a Luton machine and a WASP machine. I think it's fair to say the two main providers of commercial machines in Europe. It's always been interesting, to work alongside these two machines. Both, do the job perfectly well. I think it just comes down to personal preference. There is a certain irony with both of these machines that the Luton machine actually has a larger screw to it. It can push through more clay, but only has a small clay container. Now, it can be provided with a large clay container, but on the whole, people tend to use the small clay container that is very efficient, pushing clay into the printhead, whereas the WASP machine has a large clay container hanging off the side, and the clay is piped in, and that tends to be much slower. So although this could handle a greater volume of clay, it is not very efficient at pushing out clay very fast. Now, both companies have actually resolved this, but as we'll see later, the newer machine, the clay container is actually held in here. Luton have built the new Brute machine where large clay containers are then carried right next to the printhead. So in both cases, it has been resolved. Workshop out in Poland at Rockall. Here, I was confronted with this Polish-made machine, and I don't like. And no, it's not a criticism. I'm just going to say, as with these two companies, please, I don't want to criticise any one machine over the other. But shortcomings of this machine, one is very difficult. It's a solidly built machine, really well-built machine. But this clay container in here, one was very difficult to clean out. And this is a bit of a hobby horse of mine, and that is the consideration of the workflow. Once again, if the machines are made by engineers, they often don't know how they're going to be used. And what, for me as a user is important is to how it fits into your workflow, how easy it is to clean out, and so on and so forth. And difficult to clean this machine, but also, and I kind of flag this up for others, is that within this container, I mean, it's not uncommon, well, we all use these containers, but there needs to be a kind of a piston that then pushes the clay down. Otherwise, the compressed air takes the shortest route of least resistance, and that's down the middle. And that happened with this container. Without a plate inside that stops the air from drilling down, we then got about halfway down, and then the compressed air just forced itself down the feed pipe, whereas the feed pipe is in the back here. I think this is something that Fleming flagged up 2 weeks ago when he gave his talk. And I haven't really included software into this talk, but I think, what I call augmented reality, because it's augmenting the way, ultimately for me, we are drawing in reality. We're not working in virtual reality. I'm not using this as a virtual reality machine. But an architect friend down in Hertfordshire, I spent some time on his machines. It doesn't really work into my workflow because I work at the level of code, but I think it's kind of a really interesting way forward for actually kind of working up shapes. These two workshops, one out in Vancouver and then Boise State, brought home to me, and we're now talking 2016, 2018, that the way forward, as I flagged up earlier on as well, is rather than build from scratch your own machine, is just to convert some sort of bought-in plastic machine over to working with clay. So this machine here just had the simple glue gun type head, that won't be a stop-start head, whereas at Boise State, they had bought a print head from WASP and put it onto what is a small plastic printer, both working all right. Penn State, this is Tom Laumann here, and Tom and I have been in correspondence for some years now and have kind of done joint lectures together. And Tom invited me out to work briefly at Penn State. This was a Delta printer made by the architecture department. And then Tom has been building his own machines. I think there's another photograph coming up in a moment. And Tom and I gave a lecture together at NCECA, that is the big ceramic festival in the USA, 2018. And 3D Potter had a stand at the festival, so it was a chance to actually see the 3D Potter that is sort of, I think, once again, fair to say, the main American selling 3D printer. This, I think there's a photograph coming up later on, but this robot arm is an interesting way forward, and that is it is still only however many axes it is, 3 axes, I suppose. It moves in the X, Y, and up and down in the Z, and doesn't have all the movement that other robot arms do, but on the, is quite adequate for the way most clay printing happens. Some work of mine being shown out in France. So all of this group, I sort of spoke about using code. All of these shapes would be coming out of just one piece of code that I've written, and by moving the parameters of the code, I can start to get this morphology of form growing through the pieces. The difference in color is difference in clays that are used in the printing. Talent summer schools, obviously presenting this to ECHA, where we do the summer school. I was delighted to be invited. As I say, I think it started 2016. I'm sure after this talk we will confirm that. But 2017, 18, 19, I attended. I must move along, gosh. The strength of this school is the amount of equipment and the variety of equipment that is on offer for students to see. The robot arm has always been of kind of real interest to me. After seeing this robot arm, I put it on my Christmas list, or wanted to put it on my Christmas list. Range of Delta printers, Cartesian printers, printers using RAM feed, printers using air feed, with on-off systems, non-on-off systems. But I think one of the kind of the big it's not the benefit, I can't find the word, outcomes of all 3 years has been the pop-up exhibition at the end of the show. Within this presentation that is already running much longer than I had hoped, I haven't been able to show students' work or participants' work, but I think, it should be really interesting to be able to look over what has been done at all these workshops and seeing how things have developed. A big development, I think, at Tallinn was the cavity progressive pump, and that is, so far I've shown you machines where the clay is held in a container and there's a limited volume of clay that can be fed into the machine, and you have to then constantly change. Whereas here, you guys out in Tallinn managed to kind of sort out how to get a continuous pump to work. Another big benefit there has been really good quality clay. I'm going to get on to talk about clay just now, but I think, within the essence of good printing is good clay for me. Lowry has always produced really good clay for the participants. And I certainly remember at the last summer school that we did, someone actually said, we are forgetting the quality of the clay that we're having, because badly prepared clay results in bad prints very often, or that's my experience. At the last school we did, I put this up, unfortunately, at the last day, just as we were sort of all leaving, so it was a bit not awfully scientifically or kind of analytically done, but just on a show of hands and a bit of kind of talking, there was a discussion as to if a student or participant was to build their own machine or have their own machine, what might it look like? So first of all, in the size, this is 20 centimeters across, 40 centimeter high, 40 by 60, 60 by 100. And so the feeling was, as you can see here, a greater number of a machine somewhere around sort of 40 centimeter wide, 60 centimeter high. What sort of nozzle size they might be looking to use? Less than 1 millimeter, one participant. A nozzle size of 1 to 2, most of the participants. And then I guess some people wanting to do more architectural work or work on a larger scale, 3 to 4 millimeters. But I find these numbers interesting as to kind of where development should possibly go. So then the layer height, obviously your layer height is relevant to nozzle height, less than, a 0.5 millimeter layer height, very fine layer height, no one. The average 0.6 to 0.8 of a millimeter layer, some people happy to work larger than that. In other words, you then have a strong vision, layered vision to the work. How the material is controlled, whether it's an on-off system or continuous system. And I think by the tick, it was generally felt that an Auger printhead is advantageous. Whether the design of the machine would be delta or Cartesian, the box type structure, the delta type structure, I think this was a little unfair in that most of our machines there were delta. I've always gone with a delta because for me, they're easier to build. I'm not a technologist, but, whichever suits the box for that. The control, this was about whether it's to have an SD card, that your file is sitting on an SD card, and then you have a controller on your printer, or you can work off, you plug your laptop into the printer through USB. And interesting, the number came out more USB. Personally, and I would always want to try and influence everything, wouldn't I? I prefer the SD card system. And then the clay feed, a slight preference for an air feed over a rammed feed. Back to WASP again, 2018. This large machine actually was problematic, not necessarily for its engineering, but actually for handling of clay or the material. And for me, it sort of represents an interesting kind of dynamic here, and that is, so often we think, oh, it's an engineering problem, but we are also working with real stuff, with material, and that needs to be borne in mind. The whole ceramic process is important to this. So it really is a collaboration both between the material and the technology. Anyway, their solution is now their crane printer. So this little bit of technology can produce the same volume of printing as this. So you can see the detail here. It has a central pillar to it, and the arm revolves around the pillar. So you obviously have to be building an object that you can have the printer sitting in the middle. And then this I thought really interesting, and that is that, you know, within the development of any technologies, evolution of, you know, a lot of things, that it's not necessarily copying, but the time is right and people find the same solutions. So this was 2018. Within a month, I left Tallinn and went out to Italy, and both institutions, whatever, groups, were using the same solution for pumping clay. And to the best of my knowledge, there hadn't been any, you know, sort of correspondence between the two. You know, here they're using a progressive cavity pump to feed clay to the print head. So the print head is here. There's got a small screw in it to actually control the deposit of the clay. So the kind of ecology of this printing is that the clay is being dug up on site here, has been wheeled around into the mixer, and in the mixer they're putting a little bit of organic chaff. So that's the material that is around a wheat head. So a little bit of fiber has been added to it, and then from the mixing here it gets put into the progressive, the pump that is under the plastic, and then into the print. Finished house. Let's move on. This was another, you know, potential solution for the continuous flow. WASP had been really working hard on how to, you know, resolve this, being able to feed enough material. A pug mill being an option. The trouble is you do need to keep feeding this, and in pushing down this arm, you do tend to get a different pressure coming through, whereas the progressive cavity pump gives a much more constant pressure. And then this is kind of just my humor, I guess, is WASP have designed this printer with that the base is cut away, so the board, or you can print straight down onto the surface, and having printed something quite large that is difficult to move, you move the printer rather than the print. So this is, rather than pavement art, this is printing on the pavement. They literally just printed out. This is during the Faenza Ceramic Festival. Some residencies and kind of what I've learned through the residencies. This was the British Ceramic Biennale. Michael Eden had persuaded 3D Systems to lend him, 2016, lend him a plaster printer. I then had my extrusion printers, and I guess the objective was to try and set up a dialogue. The British Ceramic Biennale is in Stoke-on-Trent, and that is the industrial town for ceramics in the UK, particularly traditionally. And the telltale here was that the industry were not particularly interested in either of our techniques. For them, it is just too slow. 3D printing, I think, is not really an answer for the ceramic industry. This residency year, 2018, was at Laufen. That is a sanitary ware factory out in Gmunden in Austria. And I had a large WASP machine. Now they have digitally automated their production and invested a lot into digital technique, and had a robot arm that would CNC cut molds. But again, molding is the way forward for these industries. So it's not to say that digital ways of working are irrelevant to the industry, but I think it's just really printing that is less relevant than mold making. This residency out in Sardinia earlier this year, just before we all got locked down, was in a ceremony that was, still is, a traditional artisan pottery town. So it's really interesting to literally walk down the high street and see a pottery over there, and over there, look, there's another pottery over there. What the Fab Lab was trying to do and have me in residence was actually just show the traditional artisan potters, what might be doable with the new technologies. So although I did do a bit of my own work, on the whole, I worked more on making sort of domestic pieces that I hope, the local potters could respond to. So obviously making small coffee cups and then dishes over here. The outcomes of that residency in Austria.